Hi everyone, welcome back to another video on the builder design pattern in the series of creational design pattern that we are continuing. In the last video we have talked about singleton design pattern, and in this video we'll talk about the next most popular design pattern in the creational design pattern category, which is builder design pattern. So let's go ahead and talk about what is a builder pattern. To talk about a builder pattern first, let's think of a scenario that we can map in the that we can map as a mental model in order to understand why do we actually need something like builder pattern. Okay, so let's imagine that you are in a advanced shopping cart, an advanced physical store where the where you make billing by yourself, so it's like a self billing system. So you go to one of those kiosks and you start scanning each of your product that is there in your physical cart. Okay, you take them out one by one and then you start scanning them, and then you start adding those things in the list. So let's suppose you have 5 items, and then you added those 5 items in the list. Now suppose that you decided that you don't want one of these items, so while checking out you remove those items by clicking on a small cross, and then you click on the next button, and then you have a invoice in front of you with the ordered amount. If you say yes that you want to pay with the amount that is given in front of you, then you go ahead and do the checkout, and then you make the payment. Okay, and just before the checkout your final bill is in front of you, which gets printed, and you can take that bill to home or to whatever you want with that. Okay, what I want to tell you here is that this is a classical use case of something called as builder pattern. Now something to note here in this example is when you make your final invoice, which has to be paid when you have already done checkout, this invoice should not be, this invoice will have, let's say, 4 items and a amount which is generated because of these 4 items. This information in the final invoice should not be changed. In computer or programming term, this means that it should be immutable. So builder pattern enforces immutability after you have decided everything that you want to add to construct a object. So this is what builder design pattern is. It allows you to have a step-by-step creation of an object while also maintaining the contract rules for that object. Now, second term that I want to talk about when we talk about builder design pattern. So builder design pattern allows for the creation of object in a step-by-step manner, and as we saw in the case of invoice generation, it also established immutability, that is, once you create an object it cannot be changed. And then the last term that I want to discuss here is it also enforces contract. Now what do I mean by contract here, which is a very tech savvy term, or I'll say it's a very deep term that does not mean much, but in terms of contract it means that there is a certain way an object can be created, and builder pattern enforces that ways of creating an object. For suppose in the invoice example that we just saw, you have 4 items, 1 2 3 4, and in all of those 4 items the system also need you to specify a token number, which could be a random number that has been generated from that product, and that has to be put inside manually. So when you are adding any item inside of your invoice, that X number might not be provided by you, and when you click on the next button to generate the invoice for yourself, at that time the invoice generation system might give you an error before creating an invoice, because you have not specified that X factor or that token number that has been provided to you. So this is the simplest way of telling that builder design pattern establishes contract. Now let's try to understand this with the help of an actual example for the builder design pattern here. So let's try to understand the example of what builder pattern would do to class A. Suppose that the creation of class A has to happen with the builder pattern. So class A currently has two properties, X and Y. And suppose that while creating class A, both X and Y has to be provided. But the user provides only X values and forget about Y value. And in that case, the builder design pattern would give you an error. Okay, let's forget about builder design pattern for the first case. Let's just assume how would we actually enforce a contract when there is nothing called as builder design pattern in our case. In programming languages like Java or any object-oriented programming languages, to enforce a contract, we would actually need a constructor. So this code somewhat resembles of a object-oriented programming language's constructor invocation, where we provide two values X and Y. And here inside of the constructor logic, we can put one more uh, condition of checking if y if y is not provided, then we throw some exception. So this is how we will enforce contract in a non-builder pattern kind of scenario. But just imagine that you don't have just two variables or two properties of any class. Rather, you have, let's say, 10 properties. And of those 10 properties, 5 are required and 5 are not required, so they are optional. And in that case also, these 5 variables, when you try to set them, they are dependent on each other. So for suppose X can be dependent on Y for its calculation, and Y could be dependent on, let's say, Z. So and Z can in rather be dependent on both A and B. So in this case, if you see, let's suppose my class A has 1, 2, 3, 4 and 5 required properties. In that case, I would have to generate maybe more than 4 constructors or maybe more than 5 constructors, so that the combination of all of these takes place in a enforced contract manner. So builder design pattern actually solves this problem by allowing user to incrementally or step by step construct the object, and in case the user forget about providing a required or essential value in the while the object is being created, at that point we can simply throw an error to the user. Now let's visualize this by writing some code. I will first write this code I will first write some pseudo code to make you understand how the builder pattern works, and then we will go into the IDE and understand by actually implementing a builder design pattern. Okay, so how would the creation of something like a class A, which has two property in it, let's say X and Y and Z, let's take Z for also example, would take place when X and Y both are required, but we are not required to give Z. That is, X and Y are enforced via contract to be provided by the user, but Z is not required to be provided by the user. In programming language like Java, we can simply create the construction of A with the help of builder pattern with a syntax similar to this. We will first have the builder for A, so we will first have a builder for A. Then we will create then we are going to start building our A object. The first thing that we did was setting X as 1, and then the next thing we will do is to set Y as 2. So these two were required, so these two values were required, and now we don't need not to specify the Z, so we can simply create our object A by doing this, and this is going to internally invoke the creation or the instantiation of the object and will return us the object A. Now suppose that the user was not providing this value, right? So the user was not setting the value of Y, and we invoke this line of code. So I'll just label them the line number of this code, right? And if the user invokes line number 4 of the code, this is going to give us an error because this build method is going to check whether x and y both the required values are provided or not. So this is how the contract is enforced. The second thing that you have to observe here is that when you create A, it is immutable. That is, you cannot go ahead and then change the values of A until and unless A exposes some methods through which you can change the values of A. But it is generally discouraged to have setters for directly on object like A, which is being built with the help of a builder pattern. So builder pattern, as you can now see, summarizes the creation of an object in three manners, as I have mentioned before. The one is step-by-step creation, second is immutability, and the third is contract enforcement. So builder pattern makes sure that you have the creation of object in all of these three manners. So now we will go ahead and talk about the implementation of a builder pattern. So the builder pattern comprise of or I'll say the builder pattern is comprised of two major elements while you want to convert the creation of any object via the help of a builder. So I'll just call it builder pattern, and it has two main elements in it that you have to pay attention to. So a builder pattern is not possible without having a builder class that is made for the creation of actual object class. So these two both has to be there. But let's suppose that you already have something already prepared for you. For suppose you have already declared a class A, and this class A has its own behavior and logic, x, y, z, setters and getters, all of that, right? And you want to convert this class A into a builder pattern, like the creation of class A should happen with the help of a builder. So in that case, you have to create a builder class for A, which is going to do the rest of the logic. And how do we do that? Let's just see step by step by trying this out in an IDE. Okay, so I am in my IDE, and here is where we are going to create a class called as target. So target is our class that has to be created with the help of a builder, or a builder class that we create for the target. And we have to figure out at this point, like what is the thing that things we have to do in order to convert the creation, or in order to implement the creation of target with the help of a builder rather than the help of a constructor. Okay, so to begin with, I will create these three variables inside of the target, these three properties that has to be that the target needs. And I will first explain what's the problem with so here are the three variables for the target that has to be set with the help of builder. And I have created these three variables, and also I'll just create it into the normal Java bean object by I will generate the getters and setters for x, y, z, and maybe also generate constructor. So now we have a Java bean object which resembles something of what we usually would have for creation of our object. And it might be possible that a user would be sending some null values in the place of z or y, let's say. And here is how I am going to enforce my contract, by doing if y is null, or let's suppose in this case it's a primitive data type, so we are not going to set y null, but let's say suppose any invalid value, for suppose minus less than 0. So we do not want y to be less than 0. So here we are going to return or throw a new exception, and then we'll just say enter a positive. So our we have enforced the contract, but we are not building it step by step. The user would have to give the values of x, y, z in the current constructor that we have provided. But it is also true that they don't have to provide the value of z in the constructor. So we have to create another constructor where we do not provide the value of z, so that it's easier for the it's easier for the end user or the developer to just call a constructor which only requires the value of x and y. Okay, so now this is what our target class look like, and you can just figure out this from this that it's quite actually starting to get ugly already. We have some repeated code from line number 11 to from line number 9 sorry, from line number 10 to line number 14, and line number 19 till line number 22 is what something called as a repeated code. And now we can actually get rid of this code by doing something like this, where we are calling the constructor at line number 13 in the new constructor that we have created. But can you anticipate the problems that it might cause in the future when we are having the constructor logic based on another constructor that enforces contract, and it gets really ugly by the time you have lot of variables, lot of properties in a class, and you will have a lot of difficulty in managing those constructors that are based on the other constructors, and this is going to make a mess out of it. So the idea is to generate the target by building it and enforcing the contract as well as the immutability. And also, if you see, we have also exposed set x, set y and set z methods, which just kills the immutability aspect of this class. So to convert this class or to implement the construction of this class via the help of builder, what we do is we create a builder for this specific class. So to get started with, first of all, I'll just remove all the constructors that I have for this. So constructors are not required for building a object with the help of a builder pattern. And then I will also remove these setters method that is going to set the values for the constructor methods. So this is how my class would initially look like when I am trying to implement a builder pattern inside of my for my target class. Now let's get started by creating our target builder. The first step to create a builder for our target is to create a public static target builder within the target class. Now this is going to be accessible to anyone who wants to create or generate a target object. So the first thing that they can only get access to is a builder that is going to help them to create a target object. And inside of this, we are going to copy all the original variables of the target builder class. Let me just also change these to private. So now I have the same variables that I have in the target class, and I just copy pasted those in the target builder. And then I will just simply have a publicly exposed constructor for the target builder, and then finally I'll have a method called as I'll also have a method called as build. So a target builder should also always have a method, publicly exposed method called as build. So this build is going to be called when you actually would want to create the instance of the target object that you have specified. Okay, now if you don't know about something called as method chaining, we are going to use something called as method chaining that makes the target the building of target little better. So what will happen is we are going to create our object in an incremental step-by-step manner. So at a time we might not specify all the values that a target is going to be needed, rather we specify it in a chaining method or one by one, so that it has a clarity in the development of an object when the user is coding that to create the target object or building the target object. So here, if you see, we require 3 variables x, y, z. So we are going to have a setter method for all of these 3 variables, but these 3 variables are going to set the values of the target builder variables x, y, z and not the target object x, y, z. So let me create those three setter methods for these variables which are there inside of the target builder class, and then we'll see how we proceed to create the actual target object from it. Alright, so now we have created these three setters for the XYZ, and you can observe that these setters are actually setting the values that are provided on line number 9 to 11. So these methods are going to first set the values of that, and then they are going to return the current builder class that has been created in the runtime. Okay. Now the final method that we have here is to build the actual target class with the values that has been provided by the user using these three methods. So what we'll do here is we are going to now implement our build class. So here what we do is we simply do return new target, and we pass in the current builder class that has been created for us. Okay. Now you see that here we have a error that the static error that the IDE is giving to us. So in this case what we do is we are going to create a constructor for the target class, which is going to be private constructor for target, and this is going to create the target object for us. So here what we do is we just simply copy the values that has been provided by the user in the builder, and then we copy them to the target class. So we'll do this. Alright, so far you see that we have already created the target builder and also added the logic for build over here that our target builder is going to use to create the new target object that by specifying all the values that has been set. But there is one thing that is still unimplemented, which is enforcing the contract. In our original example, we wanted that the value of y should be greater than 0, or it should be positive. So in that case, while we are actually building the target object, we can specify this by either specifying that while we are building the object in the build, or we can also specify that in the target constructor. But it would be a good example that we actually do all the sanitization checks, or the checks which will defy the contract inside of the build method itself. So I'm just simply going to do this. So here we have enforced the contract. We enforce the contract that the value of y should be greater than 0 or should be positive, and we have also set the immutability of the target object by removing all the setter methods from the original target object, and then we have also removed the constructor of the target object so that it cannot directly be created. So as I told in the slide, that the builder pattern has three different things. One is the actual object class. Second is the builder for the object class. Now how do we use this builder pattern? It's quite simple now. Instead of having multiple constructors, now the builder pattern can easily be used as follows. So here we got the builder for the target object, and now we are going to do this builder dot set x0, or I'll say some other value, builder dot set y, and in this case we are going to set as a negative value on the source, and then we are not going to set the z value for the target object. Now if I want to receive the target, I will simply do this, and then let's also make one small change in the target class. So we will just print out our target now by doing sysout. We'll just print out our target by doing sysout. But as you know that we have enforced a contract that the value of y should be greater than 0, and this should possibly throw an exception while we are trying to build the object. So as you can see here that since we have enforced the contract, this shows that the value of y should be positive or 0. So in this case we will just go ahead and we'll try to change the value of y from -1 to 10, and now this should work as we expect it to work. So it correctly prints the value of target, which is 1 and 10. So this is how we actually implement a builder for the target object or any object that you want. You go ahead first with removing any kind of setters that are there so that you enforce the immutability. Then you create a builder class through which you create the actual instance of the object, and here you also enforce the immutability. And then finally you implement the build method where you bring all the values that has been provided by the user together, and then create a new target class by passing the builder object, which is then simply copies the value that has been given by the builder. Okay, so we have understood what the implementation of builder pattern looks like, and we have gone through the example in our IDE to create a builder pattern for the object called as target, having 3 different values that it accepts. But have we ever seen builder pattern in the real world scenario? And yes, builder pattern is quite powerful and quite popular in many places in the Java JDK itself. One of the best example of the builder pattern that I have observed is the string builder. The string builder class for the creation of strings is the best example for a builder pattern. You can also check out the entire write-up of my article where I have given the snapshot of where and how the builder of a string builder is created, and also how they go ahead and create the value of a string after things have been finalized for the creation of string. And as you know that the strings in Java are immutable, that is strings positional values cannot change. String, even though might be an array of characters, but also Java does not allow you to change any character at any particular index in a string. So while the whole purpose of a string builder in Java is to provide a way through which you can easily change the characters of at any value for before creation of a string, and that's what the string builder is for. So let's go ahead in our IDE again and then just try out our string builder from the Java JDK. So as you can see, I've just created a simple string builder class, and then how do we use string builder is quite simple. It has the same pattern as we have observed in the builder class for the target that we have created. In string builder we would do something like so. As you can observe here, from line number 6 to 8 we have appended 3 different kinds of objects inside of the string builder. The first object is a string itself that we have appended. Then we have at line number 7 we have appended a character, and at line number 8 we have appended a boolean value. And before creation of the string, that can also be a case where you want to remove something. So at line number 9 I'm also removing something. Since the string is not built, I can do that. So that's the beauty of builder pattern, is that before even having an immutable object with you, you can go ahead and then change depending on your business logic or the logic that you want to implement. And then finally, when you are okay with everything, that you are fine with the creation of a string of this pattern, you would just simply do a final string, and then you are going to print, once you see what values this final string has, it will be exactly what you have. So you can see the first character is A, the second character got deleted at line number 9, and then we also have we also appended a boolean value of false. So this is a very popular example. I highly encourage you that if you are interested, you go ahead and read my blog. It is available for free of cost. So anyone who is interested in learning about builder design pattern and is a kind of a readaholic can always definitely go to my blog and read about the builder pattern and all the code examples that I have just explained. And also you can check out how the string builder is actually used. So I have taken a snapshot of the actual source code from the Java JDK that shows us how the string builder is used in the real world case scenario. With that said, that was it about this video and the builder design pattern. It was so great while making this video, and I hope to see you again in the next video where I'm going to discuss about the prototype design pattern. Thank you so much, and subscribe if you have not subscribed to my channel.